Okay, so we are still solving quadratic functions using the quadratic formula. But what's different today in the learning goal says, and approximating the solutions. So remember what I said, when we can get exact solutions, even if it's an ugly, it's a fraction that has an ugly decimal name, if we can get exact solutions, then we know that that was actually a factorable quadratic. For sure it could have been solved by factoring. But not every quadratic function is factorable. So remember we said, not everyone can be solved by factoring. Not every quadratic function can be solved by using the square root method. But every quadratic function can be solved by using the quadratic formula. So I start out the notes by saying sometimes you're going to have to round the square root of the discriminant. So the discriminant, well, if you have to round the square root of the discriminant, what does that tell you right away? The discriminant is what? Not a perfect square. So whenever you end up with that b squared minus 4ac not being a perfect square, you're going to have to approximate that part of the problem. And we again are going to round to the nearest hundredth in that part of the problem. Okay? And we need to be able to do that correctly also. Okay, let's start with number 1. Is it ready for us to identify A, B, and C? Yes. Okay, go ahead and do that on your papers, please. Okay, substituting into the quadratic formula that you now have memorized, right? You got this. Substituting into the quadratic formula. What's our first substitution? What are we going to have? What's the first part of the quadratic formula? Negative b. So we have a negative sign, and in parentheses we'll sub in our b value. What's the next part of the quadratic formula? Plus or minus, yeah. Radical, so we're going to take the square root of
b squared plus negative 4 times a times c.
Okay, so the 8's going in for the b because we're going to square b. If we're setting ourselves up for success, we probably are using plus a negative 4 rather than minus 4. And our a value is 1, our c value is negative 1. And all over, what's the bottom part of our quadratic formula? 2 times a. So this will be 2 times 1, won't it? Okay. Okay, go ahead and do the next step that you know I would let you do in this. Next step of work. Do we agree? So our b squared becomes 64, and our negative 4ac becomes a positive 4. Do we agree? And 2 times our a value becomes 2, and the opposite of 8 is negative 8. So in our next step, we're going to have negative 8 plus or minus the square root of what?
8. 70. I mean 68.
68. Now, here's what you cannot do. We did not ever learn a property that says this. Never did we learn a property that says this. 64 is a perfect square. Being added to it is 4, which is a perfect square. So I can take the square root of 64, I can take the square root of 4, and I can add them together, and presto, I'll be able to take the square root, because I can break it apart like that. We never did I teach you a property like that. That you can, if you're taking the square root of a sum, you can take the square root of the parts, each part, and then add those square roots together. We did that with multiplication, but never addition. So don't be fooled into thinking right here that you can take the square root of 64, which is what? 8, and you can take the square root of 4, which is 2, and you can add those together and get this 8 plus 2 is 10. So this would become 10. No. Guess what is the square root of 68? What is 10 the square root of? 100. Yeah. So we can't do that. We have to we have to totally simplify what's called our radicand, also known as the discriminant in this case. We have to totally simplify it before we try to take its square root. Now's where we're gonna do our approximating. So we're gonna say x is approximately equal to. In other words, we're showing us and anybody else who looks at our problem that we are gonna do some rounding in. Something's been rounded in this, okay? So we're gonna leave our -8, plus or minus, and now you're gonna use your calculators to find the square root of 68 rounded to the nearest hundredth. Right now, I just want you to I want you to look at your calculator, and without rounding, I want you to tell me right now, how many hundreds are there without rounding? How many hundredths are there on your calculator right now? Better get it, the mode change so it will, but maybe classic or something like that. Okay, isn't it 0.24?
Yep.
So isn't that 24 hundredths right now? If we're going to round to the nearest hundredth, what we're really deciding is, would this stay 24 hundredths, or would it become 25 hundredths? Would it become 25 hundredths?
Let's say 24.
Why would it stay 24?
Because it's not more than 5.
Okay. What do we use to decide if it's more than 5? The next place value. So we go to the next place value, which is thousands, and if there's a 6 in the thousands place, is that enough to round those hundreds to 25 hundredths? Yes. So we have 8 and 25 hundredths as our approximating. Remember, because we had to put this approximately equal to here, so we're showing we did some rounding here. Okay. Now, what do we do next? Yeah, we break this into two separate problems. We have x is approximately equal to a -8 plus 8.25 all over 2, and x is approximately equal to a -8 minus an 8 and 25 hundredths all over 2. So now, if you have been wanting to, we really haven't shown one more step, or we've actually just kind of always, because we've been able to do it in our head, right? We've always said, if this would have been -8 plus 8, we would have done that in our head, correct? We could do that. Well, maybe this isn't as easy to do in your head, so you want to use your calculator, but you don't want to have to show one more step. You want to go straight to the answer. Anybody think they know what they better do in their calculator then? If they're going to put it into their calculator to do it all in one step? Anybody know what they better do in their calculator then? Do what?
It better be able to put the whole entire fraction in.
Yeah, if you put the whole entire fraction in, what are you going to have to do? I would like us to try this because, actually at some point of your math careers, you should be able to put everything. You should be able to understand how to put it all in right here at this step. You should be able to put it in and go straight to your answer at some point in your math career. I'm not sure we're there yet, but I would like to know that we're at least here to do this. How could we do this in our calculator in one fell swoop and go straight to saying x is approximately equal to? Okay, try something for me then. Do this in your calculator. Would you put -8 plus the 8.25 divided by, that's what that fraction word means, divided by 2. Tell me what you get.
0.125.
Point what? -3.875. Do we agree? Anybody get something else? Devontae says -3.875. Some of you are agreeing with him, and everybody else is also. So we didn't get anything else. Well, that's not the correct answer. So what do you think we have to do? What did we do wrong there that led us to the wrong answer? Because I guarantee you, the point we're at right now, we've done all the right steps. So why is the calculator giving you a wrong answer? Because I'm telling you right now that is not the correct answer. So why?
Because
Well, yeah, it says to divide by 2. So here's how we put it in, right? We put it in as -8 plus 8.25, and then we did divided by 2. Isn't that what we did? Okay, so can anybody tell me why did the calculator give us the wrong answer? You know what? We all love to use these calculators, and we all trust them almost as much as we probably do our cell phones. But yet, we're not, we're not certain why it lets us down sometimes. Pardon? Order of operations, right? So when we put it in this way, what does order of operations, what's the calculator doing first? No, guess what? It's not. It's divided by 2 because it's smart enough to know the order of operations. It knows that this is what it better do first. This is what it better do first. And then it goes back and adds that -8 to it because it knows the order of operations. So what do we have to tell it? We have to say, hey, wait a minute, calculator, though. I don't want you to follow the order of operations because I have a fraction here and I have to take the upstairs divided by the downstairs. So what are we going to have to do to redirect the calculator? Yeah, but so how would we tell the calculator that we wanted to add first? We just want to do this all one fell swoop, remember, so don't leave anybody else. Parentheses around the addition. So let's try this again. So what we need to do is, if we're going to put it into our calculator in one fell swoop, is we need to put this part in parentheses. So do that, do parentheses, -8 plus 8.25. Close your parentheses, say, okay, calculator, here's my numerator. Thank you for adding that together for me. Now divide by 2. Did you get the same answer? No, I hope you got the right one this time. What is it? 0. Yeah. So 0.125. Now guess what? They're probably going to give the answers rounded to the nearest 100 also. So what would we now rename this as rounded to the nearest 100? Yeah, so our final answer approximated is going to be 0 and 1300ths. Okay, now that we know how to give the calculator our directions, go ahead and get the other one. What's the answer for the other one now? Cody, you got it? Okay, so rounded to the nearest 100th, it's -8 and 1300ths. You guys agree with that? Did it first come out, Cody, to -8.125? Right, class? So it first came out to -8.125, like over here, this one came out to a 0.125, just so happened. And then we rounded the nearest 100th because that's how they're going to give the answers in the back of the book or wherever, on the key to our hour. Okay? So again, I bet if we didn't use those parentheses, it would not have led us to this answer. Would you just give it a try for me, please? -8, no parentheses. No parentheses. -8, subtract 8.25 divided by 2. You get the same answer? No. Yeah, so, oh, you do get the same answer. Really, Cody? Without parentheses. Oh, because your calculator puts a fraction bar, that's why. See, so it's really treating it as a numerator divided by a denominator, so that's why yours is giving you the right answer. But the rest of us, it doesn't put it in as a fraction to read the same answer? No. Okay, so I want you to be able to use your calculators to get these, because but I want you to make sure you know how to put them in correctly. Someday, take on this challenge. Try it. Figure out how you would put it in at this point right here. After you did the substitution step, you would put it in and you would go, I wonder if I can get to those answers. But here's what you'd have to do. You'd still have to put it in as 2 separate problems. You can't put a plus minus on your calculator. If you press that key, if you have a plus minus key, it's not going to do it for you. So what you would do is you'd put in the numerator adding the square root of, and then you divide by the denominator. Then you get the first answer. Then you do again using the subtraction and get the second answer. So someday you should be actually capable of putting the whole works in. It's challenging though, trust me. Okay? Okay, let's go to the back side. What do you want to do with this one? Identify A, B, and C. Elvin?
No.
Calvin, should we identify A, B, and C?
Sure.
Oh. What's A? What's B? What's C? Really, you guys are all identifying A, B, and C already? Come on, come on. What should we do first?
Subtract 2x.
Oh, so you want to move the 2x squared over to the other side? Okay, because it's only one move. You like the one move thing? Okay, I guess we can go with that. We have 0 now on the left side. What would the right side read? Okay, that's kind of a crazy 2x squared there. Okay, negative 2x squared, what? Plus 8x, because it's a positive 8x, and minus 1. Okay, now we can identify A, B, and C. Could we have renamed it a different way? Does it have to be renamed this way? No. So if we graph this one and checked out the zeros of the function, it would open which way? Down, yeah. So we have an A value of negative 2, a B value of 8, and a C value of negative 1. Okay, go ahead. Get this plugged into the quadratic formula. And remember, the equal sign is there until we actually get to a step where we approximate. We never approximate, we never get rid of the equal sign and replace it. Okay, after you've substituted, will you just check on me because I don't want to go on if I'm wrong and I've got the substitution step and the first simplifying step. Do you agree with me? Catch my mistakes, help me out. I did it wrong. Don't just change yours and think that I'm right because I just want you to take care of me here. Oh, you're doing, okay, yeah, if you're using a different A, B, and C value, then you can't necessarily, you're not going to agree with me. Anybody can help me out and verify that I'm right or I'm wrong? I'm right? Okay, thank you. I'm going to move on then. Ugh, just didn't want to, have to erase. If you forgot at some point to change it to an approximately equal to sign, are you incorrect? Yep. Once the radical sign is gone in this one, because it was 56 was not a perfect square, or at least that's what I would take the square root of, was that, did you guys, did your discriminant end up 56? Discriminant end up 56, thank you, okay. So that, in in the next step, when the radical sign disappears and we have to round because 56 is not a perfect square, now our equal sign changes to an approximately equal sign. And last but not least, our final answers should be, I'm going to go with, I have it in my notes here. And the other one. You agree with me? Maybe not? Should they be? Should either one be a negative? Because what ends up happening here, I mean, just looking at this, I can see I have a -8, I'm adding 7.48. Am I going to get out of negative territory there? So if I'm at -8 on the number line and I move over 7 4800 units, am I going to get out of negative territory? No, I'm not. So I have a negative divided by a negative. What's that?
Positive.
Positive. Over here, I got a -8 and I'm moving that way now, 7 4800. Am I going to get out of negative territory? No, so I got a negative divided by a negative again. That is a positive. These are all reasoning things we should do. You guys are way too trustworthy of your calculator. Way too trustworthy. You're just like, it is like, you know, the smartest thing almost on the earth is this calculator. You just trust it that much. Without reasoning through, oh, wait a minute. Should I just be happy with this answer or should I say to myself, oh, that doesn't make sense. Okay, anybody have any questions? Okay, then let's go to work on that.